In this video, I'm going to demonstrate how we can read a voltage versus current graph in order to solve for the resistance. This is similar to what we did in the current, voltage, and resistance investigation. So V stands for voltage. We measure it in a unit called volts. Volt is kind of the name for this. The actual technical scientific name is the electric potential difference. Remember, in order for charges to move, there's got to be a charge imbalance. That charge imbalance creates an electric field. The electric field then causes an electric force, which pushes those electrons to be there. So voltage is really a measure of the difference of electric potential from one place in the circuit to another. And we use the unit of volts to measure that. Abbreviate with a capital V. I is the abbreviation for current. We measured in a unit called amperes, or amps for short. And it is a measure of the flow rate of the electrons. So how many electrons are going by per second. When we did the experiment, we found that our voltage versus current graph was linear. And we found that the slope of that line was the resistance. So if I would write an equation in slope-intercept form, y equals mx plus b, the y variable would be the voltage, slope is the resistance, and the x variable current. And if there's no voltage, there's going to be no current because there's nothing pushing the charges through or pulling the charges through the wire. I'm just going to add some numbers here. Let's say this is 10 amps over here. And for voltage, let's do 1 and 2. So if I would want to find the resistance of that resistor, and the resistor is here, something that slows the flow of electrons, I could just find the slope of that line. Trace here, and then go over. We're getting approximately, and I'll just abbreviate, that the voltage is about 1.5 volts and the current is 10 amps. So to get the resistance, we can take the voltage divided by the current. So 1.5 volts divided by 10 amps, and that would give us 0.15. And the unit we use for resistance is the ohm. It's abbreviated with the Greek letter omega. So 0.15 ohms. If we would put a resistor in that would have a higher resistance, then we would get a steeper slope such as that one. And we could find the slope of that to find that resistance as well. So the slope of voltage versus current graph is the resistance. And we measure that resistance in ohms. Now those types of graphs, when we get a linear graph, that means we're working with an ohmic resistor. Sometimes you'll get materials that are non-ohmic. That means they don't have a constant resistance. For example, a light bulb, as a light bulb heats up, the resistance increases. So rather than a line, you get a curve like that. That is non-ohmic. In this unit, we will just be dealing with ohmic materials. So those will be linear relationships on the voltage versus current graph. Hope that helps.